With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, here one question is given. So let's see what question says. Show an electric dipole formed by two particles fixed at the ends of a light rod of length L. Okay, so the mass of each particle is m and the charges are minus q and plus q. So the system is placed in such a way that the dipole axis is parallel to a uniform electric field that exists in the region. So the dipole is slightly rotated about its center and released. So we have to show that the small angular displacement, the motion is angular simple harmonic or find its time period. Okay, so in this case, what is going on? There is a region. Okay, in this region the electric field passes through, and in this in between a dipole is placed. Okay, first the dipole is in this direction, and after some time it rotated with some angle. That angle it rotated with some angle, that is theta. Okay, so we have to calculate, we have to show that is it follow the simple angular harmonic motion or not, and after that you can calculate its time period. Okay, so first let's start. For this simple harmonic motion we have our acceleration, and that acceleration is basically equals to a is equals to minus omega square x. Okay, so we have to compare the solution with this. Okay, if it follows this equation, that means it shows the simple harmonic motion, otherwise it is not. Okay, so first see, it is rotating with some angle, so here is some torque is applied. Okay, so just write it down, the formula of the torque. So torque is equals to, in the vector form, that is P cross E vector magnitude. Okay, now we that value you can just directly put the value. So that is a cross product. So that is basically equals to P is QL E and cross product here, so sine theta. Okay, now we know that for small angular displacement, so just I'm writing it down, that for small angular displacement that value of sine theta becomes theta. So I can write it down that sine theta is equals to theta. Okay, now just put this value of torque. So the torque is now becomes QLE theta. Okay, so basically torque is applied here. You can see that it displays with some angle, but torque is doing here, so it moves it back in its initial position. So it is moving in this direction. Okay, and torque is applied in this direction. Okay, torque is applied in this, that means in opposite direction. Okay, so I can write minus sign over here. Okay, so torque is equals to minus QLE theta. Clear? And we also know that one more equation of torque, and that is basically torque is equals to I alpha. Okay, so I is what here? So basically I is the moment of inertia. Okay, that is moment of inertia. Okay, so moment of inertia for two mass system is what? So moment of inertia for, because here two mass system है, two mass system, so that is basically equals to mi is equals to 2 into so m and l by 2 whole square. Okay, so it is basically equals to So moment of inertia is equals to, from here we can calculate, so that is ml square by 2 for 2 mass system. Okay, now just put this value in this equation. Okay, in this equation. Okay, so we get that torque is equals to, now put the moment of inertia, so that is ml square by 2 dot alpha. Okay, so alpha is there. Okay, and that is and we already calculated here that torque, that is minus q l e theta. So just write it down, that is equals to minus q l e theta. Okay, so from here you can calculate the value of alpha. So it's very easy. So just rearrange it and then you can calculate the value of alpha. So that is basically equals to minus 2q le theta divided by ml square. Okay, so now we can compare with our first equation, that is alpha is equals to minus omega square theta. That means it gives the same relation. Okay, if I compare with the initial condition which I applied here, that alpha is equals to minus omega square theta, and I also get the same relation, that means it follows the simple harmonic motion. Okay, so now from here we know that omega is basically that term. That complete term represents omega. Okay. So just write it down, that omega is equals to, and omega square, so that is under root 2q le divided by ml square. Okay, and you can just ll is cancel out, so we will get 2q E divided by ml. Okay, and we have to calculate the time period of it. So now put the value of omega, and we know that omega is equals to 2 pi by t is equals to this value under root 2qe divided by ml. Okay, we have to calculate the value of t. So from here the t value is, that is basically equals to 2 pi, just rearrange it, and then we get the value 2 pi under root ml divided by qe, sorry 2qe, 2q. So that is the value which you have to calculate it here, that is t. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.